This video explains how to use PC Convey's Constructed Waterway Designer. We'll be using the example from Melbourne Water's 2019 Constructed Waterway Design Manual. The file is included with PC Convey if you'd like to have a look at it yourself. The requirements are: the low flow channel must carry a 3-month flow of 1.3 QMex, and the high flow channel must be able to carry a 1% flow of 15.3 QMex. The high flow channel grade is 1 in 250 and the low flow channel grade is 1 in 275. The entire cross-section has a Manning's end value of 0.05. The high flow channel batter slopes are 1 in 6 and the low flow channel batter slopes are 1 in 3. The low flow channel must be a minimum of 0.5 metres deep and the freeboard must be 600 millimetres. The cross-section must fit within the corridor width of 45 metres. Some of these values have been set as the defaults in preferences, so they've been entered into the Constructed Waterway Design form already. The high flow channel batter slopes have been entered, as have the low flow channel batter slopes. All of the Manning's end values are 0.05 and the required freeboard is 600 mm. The 3-month and 1% discharges have been specified, as have the low and high flow channel grades. The bench batters are not specified by Melbourne Water in this example, but 1 in 20 is a typical value, so these have been set as well. The remaining unknowns are the invert level, which we will arbitrarily assign a value of 100 metres AHD to, and this can be edited later. The bench widths, we'll try a width of 6.5 metres, and the low flow channel or bed width, we'll use 3 metres. You can save the cross-section at this point, and then check the shear stress values. Average shear stresses are now shown by default, as required by Melbourne Water's Constructed Waterway Design Manual, and the shear stresses are factored in accordance with that document. You can show the unfactored shear stresses for comparison to results from HEC-RAS, which doesn't calculate factored shear stresses. You can add bend information and check the freeboard. Information at the top of the form shows the file name, water level, and if the cross-section's on a bend, the bend factoring method being used, and whether the inside bank shear stresses are being factored. Melbourne Water's approach doesn't factor these up. Results are shown for the overbank areas and the main or low flow channel. The results show for each segment the maximum depth, flow area, wetted perimeter, hydraulic radius, side, bed and bend factors, and shear stress. For cross-sections designed using the CWD, you can't alter the grades on this form. This is because altering the grades would require different dimensions to be calculated in order for the cross-section to carry the required flows, and these dimensions are calculated by the designer. To change the grades, return to the designer and change the grades there. The new cross-section dimensions will be calculated when you check the shear stresses or save the cross-section. The cross-section width, including the freeboard, is shown at the top of the form. It can also be calculated using this button. In Melbourne Water's Constructed Waterway Design Manual, page 89, the hydraulic width is defined as the width of the 1% AEP flow. To check whether the cross-section fits within the waterway corridor, 45 metres for this example, select Overbank results from the control panel. The width of the 1% flow is shown here at just under 25 metres. The Overbank results also show that for a 3 metre bed width and low flow channel batters of 1 in 3, the 1.3 QMex low flow can actually be carried at a depth of 0.49 metres. But PC Convey has ensured that the 0.5 metre minimum low flow channel depth requirement has been satisfied. In Melbourne Water's Waterway Corridors Guidelines document, Table 3 shows that for a hydraulic width of 25 metres, a corridor width of 45 metres is appropriate. If the shear stresses are too high, it only takes seconds to change one or more of the variables and recheck the values. It may still be necessary to provide some bank protection, at least until vegetation establishes. If you have any questions or comments, please leave a message below or contact us through our website. And thanks for watching.